In this video, we are going to continue practicing graphing sine and cosine functions with reflections over the x-axis, changes in amplitude, changes in period, and phase shifts happening. Now, be careful. When you have a b value like this and a phase shift that is trying to happen, you cannot leave it in this form. Okay, similarly to the way if I have, you know what, let me use the same coefficient. If I have 3x minus 15, you know I could write that as 3 times x minus 5. And if it weren't so obvious, you could look at this and say, okay, he pulled out the 3, and then he divided by 3, and that's where he got the x minus 5 from. But you know what? You're going to have to look at it this way if you have something that's not so obvious. For example, say if I had 3x minus 7. If I still needed to factor out the 3, I could, as long as I understand that when I factor out the 3, I must divide by 3. So that would leave me with x minus, but then I will have 7 over 3. Alright, this is the form that we need when we are trying to graph a function. I can't just leave it like 3x minus 7. I have to factor out the 3 before I consider what is the phase shift. So that's what's about to happen. Okay, so the first thing we have to do is rewrite this. So when you see this 3x minus pi, pi is not the phase shift. You have to take the 3 out. You have to factor the 3 out. And if you factor the 3 out, what you really are doing is you are dividing by 3. So yeah, these 3's cancel, and that leaves you with x. But over here you have x minus pi over 3. And this is the form that we need. So I'm going to go ahead and copy this down. You know what? I guess I'll just put it right here. So I have y equals negative 2 times the sine of. Okay, now I'm going to put this parentheses, but inside I will have 3 times parentheses x minus pi over 3. Alright, so the 3x minus pi became 3 times the quantity x minus pi over 3, as I showed here. Okay, now I can go ahead and do the problem. So we have the a value right here. That a value tells us that the amplitude is 2. Notice that amplitude is always positive. This negative sign in front is a reflection over the x-axis, so we'll deal with that later. What else? We've got this b value right here. Now that b value leads to the period indirectly. The period is always 2 pi divided by the b value. So in this case, the period is 2 pi divided by 3. Alright, so that's it. The 2 pi over 3 is the period. Now, there's a phase shift right here. I'll just put PS for phase shift. There's a phase shift of pi over 3. Now, the phase shift is always the opposite of what you have right here. So you see negative pi over 3, so the phase shift is actually going to be positive pi over 3. The phase shift is crucial to graphing the function because it tells you where to put the first mark on the x-axis. So I'm going to put my first mark at pi over 3 because that is the phase shift. Then I'm going to put 4 additional marks. 1, 2, 3, 4. This will give me one full period of the sine function. So each one of these marks represents a quarter of a period. So it would be helpful to know what a quarter of a period is. Since the period is 2 pi over 3, alright, I'm going to use QP to represent quarter period. The quarter period should be 2 pi over 3 divided by 4, because it's a quarter of this period. So I'm going to take the period and divide by 4. Now we've learned that when you want to divide a fraction by another number, all you do is put that number in the denominator. So if I want to divide this by 4, the easiest way to do that is just to put the 4 right here. So that means that the quarter period is going to be 2 pi over 12, which is also known as pi over 6. So the quarter period is pi over 6. So to get the next mark over, I need to add a quarter of a period. So I need to add pi over 6. Well, to add fractions you need like denominators. So I really need to multiply the numerator and denominator by 3. That means another name for this position would be 2 pi over 6. So if I take 2 pi over 6 and I add 1 pi over 6, that's going to give me 3 pi over 6. Alright, I'm writing it up here because I know that that will reduce down to pi over 2. Alright, I'll erase that in a minute. So now I have 3 pi over 6. If I add another pi over 6, that would be 4 pi over 6. But that reduces down to 2 pi over 3. Alright, but I've got 4 pi over 6. If I add another pi over 6, that would be 5 pi over 6. If I added another quarter period, another pi over 6, that would be 6 pi over 6, which of course is just pi. Alright, so now we have everything all marked. Now, eventually we're going to need to know where the y-axis goes. So I have a positive number right here. So what I like to do is put additional marks to the left until I get a negative. That way I'll know right where to put the y-axis. So, alright, so these are the marks that I'm going to use to do my graph. But I'm sort of hunting for the y-axis, so I'm going to put another mark over here. Now going to the left from here, I need to subtract pi over 6. So remember, this is 2 pi over 6. If I subtract 1 pi over 6, that would be pi over 6. Okay, that tells me I need another mark over here, so let me go like this. If I subtract pi over 6 again, pi over 6 minus pi over 6 is 0. Alright, so that tells me that the y-axis will actually go right here because this is 0. Alright, I think I'm going to move the 0 so I have room for the y-axis. Okay, so here's my y-axis. Alright, there is no vertical shift. So that means the midline will be the x-axis. So I can just go ahead and safely put a 1 right here and a negative 1 right here. Okay. So let's just clean this up a little bit. Get rid of all these helper numbers that we did. Alright, now we're ready to do the graph. So we're graphing the sine function, which we know starts at the midline. Alright, it starts at 0. So my first dot is going to go, remember, we always start at the phase shift, which was pi over 3. So our first dot will go here. You know what, I need to change one small thing. The amplitude is 2. So the highs and lows will not be at 1 and -1. They will be at 2 and -2. So I'm not actually going to change anything except for the number. Alright, why do more work than I have to? So I'm just going to call this 2, and I'm going to call this -2. Okay, anyway, so I'm starting at the midline. Now, because of the negative sign in the front, we have a reflection over the x-axis. So normally the sine function starts at 0 and it goes up and then it goes down like that. So because this is reflected over the x-axis, I'm going to do this upside down. So I'm going to go down and then up. So from here I'm going to go down to the lowest point and then back to the midline. Then I'm going to go up and back to the midline. So this sine function graph is going to look something like this. And that's it. So that was problem number 23. Alright, let's move on to number 24. Now here again, I have a B value right here, and there's some type of a phase shift happening, but you have to be careful. The phase shift is not pi over 3. You're going to have to factor this out. So one more time, if I had 2x minus let's say 12, you know I could factor out the 2, and then I would have 2 times the quantity x minus 6. And if it was not so obvious, you could say, oh, well, I took out the 2, and to find out what went on the inside, I divided by 2. That's how I got x minus 6. See, 12 divided by 2 is 6. Now, you could do that same process if you had something that wasn't so obvious. For example, if I had 2x minus 11, I could still pull out the 2, but if I want to think about what goes on the inside, I would definitely have to say to myself, alright, if I'm pulling out 2, then I'm going to have to divide each of these by 2, and that would leave me with 2 times the quantity x minus, and then I would just have to write 11 over 2. So that's what is about to happen right now. So right now I have 1/2 x minus pi over 3. But I cannot leave it like this. I must factor out the 1/2. So I need to have that 1/2 outside of parentheses to be able to read the equation properly. Now, if I'm going to put that 1/2 out front, if I want to know what to put inside the parentheses, well, I need to divide each of these by 1/2. Now these will cancel out and I will just have x minus. But the question is, what is pi over 3 divided by 1/2? Well, I'm hoping you know that pi over 3 divided by 1/2, if you want to divide by a fraction, you have to multiply by the reciprocal. So this would be the same thing as pi over 3 times 2. So that's going to give us 2 pi over 3. So we will have 1/2 out front, but then on the inside we will have x minus, and this will be 2 pi over 3. So, rewriting the equation using this new technology, we will have y equals the sine of, okay, now I'm going to write this. So I have my 1/2, but then I have my x minus 2 pi over 3 on the inside. Alright, this is the form that you must write the equation in order to see the phase shift properly. Okay, so looking at this purple version of the equation, I see the a value would be right here. And so there's no number there. That means the amplitude is 1, so that's nice and simple. Now the b value is right here. I have a b value of 1/2. Now that will indirectly give me the period, because remember that the period is 2 pi divided by the b value, which means that the period is 2 pi divided by 1/2, which means that the period is 2 pi times 2, which means that the period is 4 pi. So the period is 4 pi. Now the phase shift, there's a phase shift of 2 pi over 3. Phase shift of 2 pi over 3. Remember that the phase shift is always the opposite of what you see right here. So because this is negative 2 pi over 3, that's why the phase shift is a positive 2 pi over 3. Now, the critical role of the phase shift is that it tells us where to put the first mark on the x-axis. So here is my x-axis. Got a little glitch going on there. Ignore the mirage down here. So the phase shift is 2 pi over 3. That's why I'm going to put my first mark at 2 pi over 3. Now go ahead and put 4 more marks on this line. 1, 2, 3, 4. Each mark represents a quarter of a period to the right. So it would be very helpful to know what a quarter of a period is. Well, okay, that's going to be extra easy for this problem. Since the period is 4, a quarter period should be 4 pi divided by 4. So that means a quarter of a period is going to be pi, of course. So that means to get from one mark to the next, I should be adding a quarter of a period, which we just decided was pi. Alright, so I should be adding pi each time to get to the next marking. So the question is, what is 2 pi over 3 plus pi? Well, pi is very easy to add, because if I want like denominators, I can just think of it as 3 pi over 3. Easy. So let me change colors so everything matches. So if I have 2 pi over 3 plus 3 pi over 3, that's going to be 5 pi over 3. So that's going to be my next mark. Alright, this is really annoying. Alright, if I add another 3 pi over 3, then that's going to be 8 pi over 3. If I add another 3 pi over 3, that's going to be 11 pi over 3. This is really annoying. Okay, if I add another 3 pi over 3, that's going to be 13 pi over 3. Okay, so that's it. None of these reduce, so I don't have to worry about that. So these are the 5 markings that I'm going to use. Now, the y-axis, I want to know as precisely as possible where to put the y-axis. So whenever I have just all positive values, I like to put additional marks to the left until I see a negative number. So, okay, so here comes a mark to the left. So of course, if I want to move to the left, instead of adding pi over 3, this time I'm going to subtract 3 pi over 3. So let's see, if I do 2 pi over 3 minus 3 pi over 3, that is going to be negative pi over 3. So I already get a negative number. So right there, that tells me that the y-axis is going to be in between here somewhere. Alright, the y-axis is at 0. So that's how I know it'll be between the negative and the positive. So I'm just going to go ahead and draw my y-axis right in here. Okay. There is no vertical shift, and the amplitude is 1. So that means I can safely just go ahead and put a positive 1 and a negative 1 on my y-axis. Alright, positive 1, and this is negative 1 right here. Okay, so I think it's time to go ahead and do the graph. So remember, the 2 pi over 3 was the phase shift, so that's where we begin the actual graph. This is a sine function, and the sine function starts off right on the midline. There's no reflection over the x-axis, so I'm going to do the usual pattern of going up, and then back to the midline, and then down, and then back to the midline. Okay, this little mirage thing is really distracting me. Okay, so it looks a little goofy, but you get the idea. So that is basically what this graph should look like. So that was problem number 24, and we are done. Alright guys, that's going to do it for this video. Go ahead and click here in the red apple to watch the next video. Click in the green apple to subscribe, or click the yellow apple for the full playlist.